Let's learn about selection statements in C in this video. Selection statements in C checks for a condition, and depending on whether the condition is true or false, you can select what statement has to be executed. So types of selection statements in C, you can classify them as the ternary operator or the conditional operator, the if statement, and under the if statement we have several types like the simple if, the if else. When you are checking only for one condition, we can use the if else, and if there are multiple conditions to be checked, we have the if else ladder, and then we have the nested if, and a third type of selection statement called the switch case. We'll look at the syntax of each of these types. So in the ternary operator, the syntax goes like this: you provide the condition, following by the condition will be the question mark and the colon. The following the question mark, what you mention will be the statement that will be executed if the condition is true, and following the colon, the statement to be executed if the condition is false. And in the simple if, we only have the condition checked, and if the condition is true, what statements are to be done are mentioned. If the condition is false, it's not explicitly mentioned. So whether true or false, whether the condition is true or false, the subsequent statement following the if will be a common statement that will be executed. Again, if there is only a single statement that's to be executed for the condition, the curly bracket is not needed. When more than one statement is to be executed for a given condition, whether it's true or false, then we include the block, that is a set of statements to be executed if the condition is true or if it's false. So when you have the else part to be included, what happens when the condition is false? We have the if else structure. So if the condition is true, a statement to be done, otherwise a different set of statements to be done. Now if you look at the nested if, here there are multiple conditions that you can check as against the second syntax where only one condition is checked. If condition 1 is true, I go on to check if condition 2 is true. If that is true also, then I check if condition 3 is true, and so on. We can have any levels of nesting happening here, and the corresponding statement to be done if condition 3 is true, otherwise it's a different statement that's to be done. So this particular statement will be done if condition 1 is true as well as 2 is true but 3 is false. And this particular statement in the else will happen if condition 1 is true but condition 2 is false. So depending upon how you have indented the statements, understanding which part of the which statement is performed for which condition can be understood easily. And then the if else if ladder. So the if else if ladder is where you can have multiple conditions checked, and the final else part is done when none of the above conditions are true. And in the series of conditions that you have given, at what point a particular condition is true, only that statement is executed and the rest of the statements are ignored, rest of the conditions are ignored. Now the switch case is another form of selection statement where based on the condition we switch to particular case values that we mentioned using the keyword case. So after the case, whatever value the condition will result in, based on that we decide which statement has to happen. Following every statement, the jump statement break is compulsory, it's mandatory, otherwise it causes a situation called fall through. We look at the fall through condition using an example. So if the missing break, when a break is not included, a missing break will cause all the statements to be done until the end of the block, and the default is similar to the else in the if else if ladder, where the else is performed when none of the above conditions are true. Same is the case for default. The statement mentioned in the default will be done when none of the above cases are matching, and the default can appear anywhere. It is not a compulsion that it has to be the last statement of the switch block, but wherever you mention the default, anywhere the default is mentioned, the section corresponding to the default will be done if and only if all the given cases have not been satisfied. So let's look at examples to understand each of the selection statement. Let the first code we'll attempt to do is to check if a given number is odd or even. I've declared a variable and I've read the value using scanf. Now to use a ternary operator, I'll have the variable, the mod operator 2. So when the value when divided by 2 results in a remainder 0, then it's supposed to be an even number. So in the true part, I will have a printf. Probably I might want the value to be shown. Supposing I enter a 20, I'll want 20 is even. So for showing the variable, I'll have a placeholder and then say is even. And following that, I'll mention which variable has to be displayed for the placeholder that's mentioned. And if the remainder is not a 0, so in the false part, I will have its corresponding print statement with the placeholder to say the number is odd. And for the placeholder, I'll display the variable num. Let's terminate the statement with a semicolon and we shall compile. I'm pressing the F9. Let's execute. So the number is to be entered. Let's enter a value 22. I'm getting the answer 22 is even. The next example we'll see is to find the biggest of three numbers. Now just like we have nested ifs, we can nest the ternary operators also. So let's have the three numbers read. I have a common message given, enter three numbers. So in my scanf, I can have the placeholders, the format specifiers for reading all the three variables, and correspondingly address of A, address of B, and address of C. Now with the three values read, now I can have a variable say result. So in the earlier example we saw, in the true part and in the false part we directly included the print statement. Here we'll see how in the true part and the false part a value can be returned, which can in turn be stored in this LHS variable result. So what this result is supposed to store, supposing A is greater than B, so it could be true, it could be false. If it is true, I'll further check if A is greater than C as well. So this particular ternary operator, it will have its own true part and its own false part. So for better understanding, if I put additional parenthesis here, so my true part here consists of yet another ternary operator. So if you can follow the parenthesis here, so this whole thing is going to be executed if the condition A greater than B is a true value. So in the true part, I'm having one another ternary operator nested. So what is that ternary operator? It's checking whether A is greater than C. So if it is true, then we can infer, since A is greater than B as well as A is greater than C, then A is the biggest value. So this value A is going to be returned and stored in the left hand side variable. Supposing A is greater than B but A is not greater than C, then obviously it will mean C is the bigger of the two. Supposing A is not greater than B, then the control goes to the false part straight away. If A is not greater, so B is greater, that is the inference. I'll further check if B is greater than C as well. So I'll come to the false part of the outer ternary operator. If B is greater than A, I'm further checking if B is greater than C as well. So if it is true, then obviously my B is going to be the bigger value. Supposing it wasn't, then C is going to be the bigger of the two values, bigger of the three values. I have to print the value of result. So the biggest number can be shown as, biggest of three numbers can be shown as %d, and for that %d I shall mention what is stored in the variable result, and I'll terminate. So let's execute and see. Let's give the three values as say 20, 25 and 18. So the biggest number is 25. So like this you can have any levels of nesting happening in the ternary operator as long as you follow the order for every true part and the false part, whether the statements are written properly. Now the next code, we'll see one example for a simple if. So I have a variable age declared. I've read the value for age. I want to check if a person is eligible to vote. So if age is greater than or equal to 18, now definitely we have to check for a upper limit also, or else if I give a value for age something like 2045, then it's still going to be true. 2045 greater than 18 is true, so that's definitely not logically right. So we can have a upper limit, assuming the maximum age a living human being, we can consider 100 to be the valid age. Now to check if age value entered is between the range 18 and 100, so greater than equals 18, logical and age lesser than equal to 100. So this will be the way you can check for ranges. Unlike in Python, what we used to do as the lower limit lesser than equal to age lesser than equal to 100. This is not okay. This kind of chain relational operators, though it is available, it is not okay to use this for checking for ranges, because supposing I enter a value, let's say I'm entering a age 14. So I'm entering a age 14 here. So you substitute 14 for age. Now is 18 lesser than or equal to 14? It is not true. 18 is not lesser than 14, and false is going to be represented as a 0. So this result will be a 0, and the next check that will happen is 0 less than equal to 18, which is definitely true. So this will result in a true value. So this is going to be understood as 14 is in the range 18 to 100. So this chained relational operators is not going to work all right when you want to check for ranges. So the correct way of checking for ranges will be the variable greater than equal to the lower limit, logical and the variable lesser than equal to upper limit. So if this is true, I might want to have that message printed as eligible to vote. Now supposing the condition is not true, I am not going to mention anything, and that's what my simple if does. And whatever statement comes aligned with the if here, that's going to be a comment statement. This comment statement is going to be done irrespective of whether the given condition is being true or false. So I can probably give a message the code is being exited. So in case of the simple if, the else part is not included to say what is to be done if the condition is false. So let's execute this and see. Supposing I give the age to be 35, now it will say eligible to vote and exiting. Of course I had not included the slash in, but if I'm re-executing the code with a different value, and I enter a value say 12, then it only says exiting, because I have not mentioned what is to be printed if the condition is not false, like I have not included not eligible. So a simple if does not include the else part. So now to look at an example for if else. Now if I had included a else part for saying what's to be done if the condition is false, so in the else part I can print not eligible to vote. Now to look at an example for if else if ladder. This is a menu driven code. Option 1 in the menu is to find the area of the square. Option 2 is to find the area of a rectangle. Option 3 is to exit. A variable choice has been declared, and the value of the choice is read from the user at runtime. Now depending upon the value the choice holds, if it's a 1, then I shall read the side of the square and then compute the area. So because it is more than one statement that's to happen, then I have to be representing that using a block. So if my choice is a 1, I'll ask the user for the side of the square, and a variable side declared. I will read the value for the side of the square by mentioning the format specifier, the address of side, and using this I shall print the area of the square to be %d, the placeholder which will store the result of side times side. And all of this is to happen if the choice is 1. So when you have multiple statements to be performed in the if part or the else part or the elif part, then the curly brackets to represent the block can be used. Supposing the choice was not a 1, so else if choice is a 2. So this again is going to have a series of statements to be executed, like I'll have a variables for length and breadth. I'll ask the user to enter the values for length and breadth, and I'll read the values for length and breadth. Scanf. There are two variables to be read, so the format specifiers for both: address of the variable length, address of the variable breadth. And with these two values read, I shall print the area of the rectangle to be again a placeholder for representing the result at that point, and for the placeholder the expression is a L times B. Now if the choice is not a 2 as well, then I can go for a else directly, or if you're expecting the user to enter any other value other than 1, 2 or 3, because that's what my menu says, the valid options are 1, 2 and 3. If you expect the user to enter any other value, then you can continue to have a else if. So if the choice is a 3, then I can, it's just going to be one statement which I'll print as the code is exiting, and in the else part, so this else will mean if the user had entered anything other than 1, 2 or 3, then I can have a message to show the choice is invalid. But if you're expecting exactly 1, 2 or 3 to 1, 2 or 3 to be entered by the user, then even the elif is not needed, else if is not needed. In the else part you could have included the exiting message. So let's execute this and see. So if I enter a value 1 for the choice, then the side of the square is red and then the area of the square is shown. Supposing I rerun the code, and this time I enter a choice 2, the length is a say 6 and the breadth is a 3, then the area of the rectangle has been computed. And if I re-execute this with the choice 3, the message exiting has come. I re-execute this entering some other value or random value, then an invalid choice has been displayed. So let's look at an example for nested if. I have a variable mark declared, and I've read the marks from the user, and depending upon the mark I'm going to assign a grade. So I'll first check, because it's a nested if, I'll have a condition if mark is, let's say, greater than or equal to 40. So assume for now if the mark entered by the user is say a 92. So 92 is greater than 40. So I'll enter the next level to check if the mark is greater than or equal to, let's say 75. So 92 is definitely more than 75. I'll further check if the mark is greater than or equal to 95. So let's assume 95 and above is considered to be A grade. So if the mark is more than equal to 95, my grade variable is going to be assigned with A grade. Now since it's a single character, it has to be enclosed in single quotes. Strings are enclosed in double quotes. This else part will mean the mark is more than 75 but less than 95. So like in case of 92. So in which case the grade can be assigned to a B, Now this else will mean the mark is more than 75, but it is not greater than more than 40 but not greater than 75. Let's say the mark was a 62. So 62 is more than 40 but it is less than 75. So the control comes here. At that point, let's say the grade is a C, and this else will mean the mark is less than 40. So supposing my mark was a 32. So 32 is less than 40. So straight away at that point this else will be executed, and let's say that grade is a D. So let's execute this and see. So let's enter the mark to be a 92. Okay, I have not displayed the grade. So finally in my code I must have displayed the grade. I have been only assigning the value for grade. So I should finally say for, let's say, your marks percentage D, your grade is, now grade is a character, so the format specifier for character should have been a percentage C. So for the first placeholder percentage D, let's show the mark scored by the user, and for the second placeholder the grade that has been assigned based on the above computation. So let's execute this and see. So let's enter the mark to be 92 again. So for your marks 92, the grade is a B, because 95 and above is a A grade. 75 to 94 is a B grade. So the grade has been shown as B. The next example we'll see is about for a switch case. We're going to read a day number, say 1 to 7, and depending upon the number the user has entered, we're going to display the day name. Let's start 1 with a Monday. So the syntax goes like this: switch, and in parenthesis the variable that we want to compare, check, and then switch based on that value. So in case the day value stored a 1, so this is how we use the syntax: case space and the value that the variable can possibly take. So if it's a 1, I want to show it's a Monday. Now we'll quickly copy paste these values. So if it's a 2, I want to show it's a Tuesday. If it's a 3, I want to show it's a Wednesday. If it's a 4, it's a Thursday. If it's a 5, Friday. If it's a 6, it will be Saturday. If it's a 7, we'll display it's a Sunday. Now the user, in spite of showing a prompt, enter values between 1 to 7 here, the user need not be following the prompts that we give. So user could have entered any other value. So that has to be taken care of through our code. So that is where a default can come in use. So in case the variable day is not storing any of the values 1 to 7, then I can have one message saying invalid day number or invalid value. Now let's execute this and see. So let's assume we are entering a value 2. So see what's happened. So when I enter a value 2, it obviously does not match with a 1. So from the part where the data matched, the value matched, all the cases are done including the default, and this is what is called as fall through. So a fall through in a switch case is caused because of a missing break. Every case after the statement has been mentioned, we have to be including the break as well. A missing break will cause a fall through starting from the matching. So supposing I had given a value 4 instead of a 2, then where is the matching case? 4, it will be a Thursday. So all the statements starting from that matching case till the rest of the switch block, so Thursday, Friday, Saturday, Sunday, invalid value, all of them will be displayed which is called a fall through. So to avoid a fall through, we have to include a break. So every statement after the statement that you have mentioned for the case, we have to include a break. The last statement alone need not have a break, because anyway that's going to be the last statement of the switch case block. So every other statement will have the break included. The last statement need not have. If you put a break also, nothing wrong, but it need not have the break, because even if it falls through, that is anyway going to be the end of the switch case block. So with this break included, let's see the effect of the break. We'll execute the code and see. So let's enter the day 2 again. So this time it will just show the statement corresponding to case 2 and the code stops. And also, like I said, the default need not come as the last statement. The default can come anywhere in between also, but wherever you put. So supposing I have included in the third position, but in that case I definitely must have had a break, because it's a statement that's coming in between, and here case 7 now becomes the last statement, so that need not have a break. So even though the default has come in between, this check will be done only after the given cases are being checked. The given case values, if none of them are matching only, the default is going to be executed. Let's have a look at that. So assume we are going to give a value that is outside the allowed range 1 to 7. I give a value 12. Then the invalid message is shown, which corresponds to the default. So even though the default occurred somewhere else other than the last position, the statement against default will be executed only after checking the other cases, and when none of the case matches, then that's when the default block is going to be executed. Just like we had nested if and nested ternary operator, we can have nested switch case also. So in this particular situation, we're going to have an outer menu. The main menu is going to show options 1, 2 and 3 corresponding to area, perimeter and exit, and that choice I'm going to read using a variable ch1, and depending upon the choice I'm going to show a sub menu. So I'll have a variable declared for the sub menu, where the sub menu is going to ask for whether the thing is for the operation has to be performed for either a square or a rectangle. So for each of the operations, let's have the variables declared: S to store the side, L to store the length, B to store the breadth. So all my variables declared. Let's proceed. So I'm going to switch based on ch1. So ch1 is the variable corresponding to the main menu. So what can the ch1 have? It can have a 1, or it can have a 2, or it can have a 3, because 3 corresponds to exiting. And if the user enters any other value other than 1, 2 or 3, I'm going to take care using a default. Now within the case 1, let's say I'm having my print statement happening, which is going to show the sub menu. So in my sub menu, I'll have a option shown as the first option to be for a square, the second option to be for a rectangle, and depending upon the choice the user has I have to ask for the second choice, that is a submenu's choice. So I'll read it using the variable ch2. So depending upon the ch2 that has been read, I'm going to start my inner switch. So its own block for the inner switch. What can this ch2 have? It can have option 1 to represent the square and option 2 represent the rectangle. So if it is a square, I'm going to read the values for the side. So I'll prompt the user to enter side of the square, and that value I shall read using a scanf, the format specifier &s, and with that I'll get to show the area of the square, because option 1 case 1 corresponds to area. So under area, case 1 corresponds to square. So I'm going to show the area of the square to be, I'll have the placeholder here, and probably I'll want the unit shown as square, so many square units. And what's to come in the place of the placeholder? Side times side. Now the break for the end of case 1 of the inner case. Now in case it's a case 2 which corresponds to rectangle, I'll prompt the user to enter the length and the breadth, and I'll get the values using a scanf. The format specifier for both L and B, ampersand L, ampersand B, with these values read. This time it's going to be area of rectangle, the placeholder for showing the result, and so many square units. And for the first place, the placeholder here, the expression will be L times B. And the break for the case 2. If the user enters for the submenu anything other than 1 or 2, then we can take care of that using a default. This is the inner default, inner switches default. So where I can say invalid submenu choice. Now I'm done with my inner switch of case 1. So case 1's break, it's so important that you include the break here. If you miss the break here, then even if I had chosen 1, the statements under 2, statements under default will all happen, which is obviously a fall through. Now for the case 2 corresponds to perimeter. So again for the perimeter, I have to ask the user whether it is a square or a rectangle. So to save time, let's just copy paste these statements. So this will all come under case 2. The menu is shown, the choice is red, the side is red, and here the perimeter is to be computed, and the expression will be 4 times side, and here the perimeter of the rectangle is to be computed, and that will be shown as 2 asterisks L plus B, and again a default to take care of an invalid submenu. This is the break corresponding to case 2. Now supposing it is a case 3, that is exit of the main menu, I can just show I am exiting, and obviously that should have had a break as well, and this default will correspond to the auto menu's invalid choice. So that is a main menu's choice. So hope this nesting was clear. We'll execute this and see. So let's say for the outer menu I am giving a value 1. The inner menu is shown. Okay, I must have given a message for asking for the choice. So inner menu 2 I have chosen. So the length and breadth are being asked. So length is a 12 and breadth is a 8, let's take. So area of the rectangle has been computed as 96 square units. So just like a if can be nested, a ternary can be nested, the switch case can also be nested. So the examples we've seen under switch case, we saw a switch case is used when I'm checking the variable that's been checked in my switch happens to hold one fixed value, a fixed constant. So in the day code we saw the variable was holding a value 1 to 7. In the choice code we saw it was holding just fixed numerals. Now we'll look at one last example where in a switch case I can have an expression also. Take the case where I have to find if a given number is either positive or negative or 0. We'll look at this code using all the 3 selection statements we've seen so far. So first will be the ternary operator. So in the ternary operator, I'm going to have a condition first to check if the variable num is greater than 0. If it is, then I'm going to print it's a positive value. If it isn't, then that's the next possibility is it could either be lesser than 0 or equal to 0. So I'm in the false part, I'm having yet another ternary operator to check whether the number is lesser than 0. If that is true, then its true part I'm going to print the given value is negative, and in the false part I shall print the given value is a 0. So let's execute this and see. So let's say I'm entering a value minus 19, then it has shown negative. We'll redo this code now with the if. So if the number is greater than 0, then I'll print its positive value, and if it isn't, I'm going to have the else if part to check whether the number is lesser than 0. If it is, then I'm going to print its negative, and if that is also not true, then I could just have the else part to show the given number is 0. Let's execute this and see. So let's assume I'm giving a value, say 25, then the answer has come as positive. So this was done using the if else ladder. Now we'll try the same thing with the switch case. Now what I could have done is, so this is just to show a switch case you need not necessarily have fixed values to check. So I'm having in my switch num greater than 0, an expression. Anytime a relational expression is going to result in a true or a false, and here we know true is a 1 and false is a 0. So in case it's a 1, so obviously this means greater than 0 resulted in a true value. So this printf will have positive and its corresponding break. But in case it was a 0, so num greater than 0 resulted in a false. So what could it be? There's a possibility that the number was either less than 0 or equal to 0. So we'll now have a num less than 0 check done, and this switch can again result in either a 1 or a 0. So num was less than 0 resulted in a true value, then obviously that number was negative. So its corresponding print, and I'm having its break as well. Now either a default or a case 0. So a 0 less than 0, supposing the number was 0, 0 less than 0 will be a false value. So at that point I can have 0 printed. Now because this is anyway the last case of my switch case, there need not be a break following the nested switch. If you put a break also nothing wrong, but it's not needed. Let's execute this and see. So let's give a value, say 25. So it has shown positive. Let's re-execute this with a different value, let's say minus 19. It has shown negative, and let's re-execute this time entering a 0 itself. It has shown a 0. So in your switch case you can make use of an expression too, which will result in a numerical value. So with all the examples shown, I'm sure you would have had a good understanding of selection statements in C. The next video, let's learn the iterative statements in C, which will include the entry control loop and the exit control loop.